Okay, picking back up in lesson 5.4 from yesterday. We are ready to start example 3. And as you look at example 3, given that cosine theta is 7/25 and sine theta is greater than 0, being asked to find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. Now, before I started the recording and everything, I suggested that you could start this because this is a similar problem to number 1, correct? Now, the difference is on number 1, they were 2 theta, 2 theta, 2 theta, so we had to use the double angle identities, right? The big difference here is that we're not going to use double angle identities. It's theta over 2, which means we're going to use our half angle identities when we get to that point. But if you look at the half angle identities up above, so let me slide for a moment. Okay, we're going to be using these half angle identities. What is it we have to know to do half angle identities? We have to know cosine for this one. We have to know cosine for this one. We have to know sine and cosine for that one. Technically, what do we not have to know then? You don't have to know tangent for this one. Now, if you already found tangent, great. I told you to start at like number 1, so it makes sense. So we need to start off making sure we know sine and cosine. We know cosine. That's good news, right? Okay. And we know sine theta is greater than 0, which means that is positive. If cosine is positive and sine is positive, then together we're going to be in quadrant 1. So when I draw my triangle here, we go up from the origin. Your triangle is always on the x-axis. And your angle is at the origin, right? At the origin on the x-axis. What do we know about our current sides? Okay, good. Cosine is adjacent over hypotenuse. So that means our adjacent side is 7. Our hypotenuse is 25. Can you guys tell that this was supposed to be a theta?
Yeah. It looks more like when you're trying to differentiate O and a 0, so you put a line to the 0.
Yeah, it kind of got goofed up, but realize that that's my theta. Okay, now, we already know yes, I'm in the glare. Got it. Okay, so we already know cosine is 7/25. What do we have to know to do sine?
The other side. And it's 24.
Okay, so Pythagorean theorem is going to tell us the other side, isn't it? And so if I think 7 squared plus y squared equals 25 squared. So 49 plus y squared equals 625. And that's where my mental math stops. Okay, we're going to have to do 25 squared, which was 625, minus 7 squared, which gives us 576. And what can you find about the square root of 576? It's 24. And it's not that I wasn't believing you, Stella. I was just proving to your classmates. For anyone that might need the gentle reminder of Pythagorean theorem. I would like to think that of all things you walked into pre-cal with, you walked in with a solid understanding of Pythagorean theorem. I know we have weaknesses here and there. I would like to think Pythagorean theorem is not one of them. But
in my addition,
your addition's pretty good too? Okay. Okay, so if I write down just what I have, we already know cosine is 7/25. And I know sine now. What is sine of theta? Opposite over hypotenuse, 24 over 25. Okay. You got that information to go in? We do not need tangent. If you look in the half angle identities, none of them require the use of tangent. If you found tangent, wrote it down, more power to you. It doesn't matter. It's not like you had to do extra work to find tangent, really. So, okay. So we are asked to find sine of theta over 2, correct? So the first thing I'm going to write down is my formula. And if you look up above, what is the half angle identity for sine of theta over 2? Okay. Plus or minus the square root. I wrote 1 minus cosine theta over 2, only because we're working with thetas. I don't care what variable you write. Okay. With that in mind, can we start filling stuff in? Now, the plus or minus. You have to identify, is this plus or minus? And here's the idea. If theta, this was theta over here, right? If theta is in quadrant 1, where is theta over 2 going to be? Also quadrant 1, because theta divided by 2 gets smaller, so it's still got to be in quadrant 1. So with that, I automatically know that instead of plus or minus, in this particular problem, it's going to be plus. So I can drop off the plus minus because I know it is going to be plus, because we're in quadrant 1. Okay, so positive quadrant 1. Okay, fill in what you know. 1 minus, what was cosine theta? 7 over 25 divided by 2. Okay. How do I subtract the numerator? 1 is 25 25ths, right? Because if we're trying to do 1 minus 7 25ths, I need a common denominator. And 1 is 25 25ths. What is 25 25ths minus 7 25ths? 18 25ths. Now, divided by 2 is multiplying by 1 over 2. 1 half. Multiply by the reciprocal. Keep, change, flip. Whichever one you're looking for there.
Just so I have something to write down. Sorry.
And I don't know. Do you guys want the long version of? How lost are we on getting from 8 to this to this? Okay. Okay. Backtrack for a moment. What is 1 as a fraction with a common denominator? So on top, I'm going to be doing 25 over 25 minus 7 over 25. Correct? 25 25ths minus 7 25ths is going to be 18 25ths. Now, officially, it's 18 25ths divided by 2. 2 as a fraction is 2 over 1. So 18 25ths divided by 2 over 1 is keep, change, flip, 18 25ths times 1 half. Feel free to write that down if you can squeeze it in, or on the back of your paper or something if you want to. Are we good there? So we have to be able to do, it's basic math in a way. It's just, you have to be able to think through it. Yeah. Okay. Now if I slide this over, and the key is that is all officially under a square root, right? Now, my brain I know you guys aren't. I'm a cross canceller.
Yeah, the 18 and the 2.
18 and the 2. What do you know about 18 and 2? Makes it easier in my brain.
It does the reduction.
18 and 2 become 1 and 9. So then, yikes, I had one more line I wanted to put in here. I should have just gone over, I guess. So now what do I have under my square root? Under my square root, I have 9 over 25. Because 18 and 2 cancel to be 9 and 1. So 9 times 1 over 25 times 1 is 9 25ths. But what do we know about the square root of 9 25ths? Square root of 9 25ths is 3/5.
So I waited until so I got the 18. I got the square root of 18 over 50, and then I just reduced the 9 over whatever. But I know that wouldn't work for some of the ones that have like really big numbers, right?
Technically, it would work. It'd just make your reducing harder. So yeah. So the comment was made that Ross said he multiplied and he said I had the square root of 18/50ths. That's fine. You just have to realize, don't stop there. 18/50ths reduces to 9 over 25, and then you take the square root. I encourage cross-canceling because the bigger the numbers get, the cross-canceling will make life easier. Reducing 18/50ths, that's not horrible. That's not bad at all. So if you multiplied before cross-canceling, you could probably still catch it. But when I get big numbers, it's easier to cancel smaller numbers than big numbers, is my opinion. I guess I can do it more mentally, is what I don't have to grab my calculator as much. So, no, both will work. Yes. Yeah, if the fraction under the square root does not reduce, you would leave it under the square root. Now, I will say also one thing. If, say, the numerator didn't reduce, but the denominator does, you could take the square root of one and not the other.
But what about, so if it was like, say it was 26, and then...
If neither of them can reduce, if you can take the square root of neither, in this section we're going to be able to take all of our square roots.
Okay.
I'm trying to think what happens in homework, and I don't remember off the top of my head.
We can't have that square root on the denominator, right?
And that's where I can't remember if they are rationalizing or not. I don't know that they're necessarily rationalized.
So like in our homework, if we do it with one of the denominators of the square root, then it won't be too upset about it? Or?
Not in homework, because, homework we can still fix it and I can still adjust, So, okay. You guys ready to try number 2? Or part 2? Okay. This time, we're being asked to do cosine of theta over 2, which is plus or minus the square root of 1 plus cosine theta over 2. Got it? That was the easy part, yes? Fill in your radical. Now let's talk about, is this going to be a positive radical or a negative radical? Why positive? You're getting the gist. We're still in quadrant 1, aren't we? Okay, so it's positive again because, hello, if your first angle is in quadrant 1, you're just in quadrant 1. Make life easy, right? 1 plus cosine theta was 7/25 over 2. Now, in all honesty, this is pretty much the same as sine except plus instead of minus. Can you stay a step ahead of me this time? One plus 7/25.
25 over 25 plus 7 plus 7 over 25.
25 over 25 plus 7 over 25, which is 32 over 25.
And then multiplied by 1 over 2.
Right. Dividing by 2 is like dividing by 2 over 1, multiplying by 1/2. If you need the visual, and I go back to my paper over here, okay, this became plus. This became plus. So instead of 18, we had 32 over 25. So this is, instead of 18, 32 over 25. Like how I just changed that work there. Okay. So, some of you kept working, that's good. I, again, would cross cancel. Either that or you either reduce 32 fiftieths. Again, not horrible, right? Or 32 and 2, in my opinion, both divide by 2. And so, when we multiply, we end up with the square root of 16 25ths, which happens to work out beautifully again to be 4/5.
Don't we not have to find tangent on this one, or we still find it?
No, we do, because it's fine to
Okay,
take
so
it
we can
to,
have
so.
But, quick question about that. So since, because this would still be the theoretical triangle, right? But the sides would just be cut down to those values instead of the ones that were originally there, right? So if sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent, couldn't you find tangent just by taking the tops of those two and putting them over together?
That's what I was talking, that's what you're thinking.
Is that plausible or like a test or something you need to see?
Oh, you're talking about here.
Are you talking about like Sokotoa?
See, I was thinking about the same thing.
Yeah.
Well,
Because we have.
that's opposite, that's adjacent.
Yeah. And that's what we're
Okay, so it took me a moment to follow what you're talking about. In a normal, so like if we backtrack, I mean, here's what it's going to come down to. In a test, I might not necessarily ask for all three. You know, so if I just ask for tangent, you're not going to have cosine and sine to work off of. But so, like back here, when we were finding sine and cosine here, I would definitely agree to that there, that since this is adjacent over hypotenuse, this is opposite over hypotenuse, and since the tangent is opposite over adjacent, then yes, you could just take those top numbers. And that is always true. Because you also think about tangent is sine divided by cosine. And when the denominators are the same, they end up canceling out. In this situation, it is true. To be honest, though, I would encourage you to practice using the identity in this case, because otherwise you're not getting the practice using the identity. Because it is theta over 2, it would have that same relationship. I would have to agree there. Is that a valid answer? I'm trying to be reasonable here, but
I worked ahead and I did the math and I noticed that. I'm like,
yeah,
So
there is a connection.
I was just making sure that was supposed to.
Yep.
Still be there.
Okay, tangent of theta over 2. Yes, we have to find tangent of theta over 2. What I said earlier we didn't have to find was tangent theta in the original part, just because we're never going to use it.
Yeah, I just realized that.
Yeah, because what is our definition for tangent of theta over 2? Sine theta over 1 plus cosine theta. I mean, heck, this is our first time using sine. We almost didn't have to find sine here. So, okay, notice there's no plus or minus. But there's no plus or minus because sine and cosine are used, and they will help determine that. Okay, if it would need to work out as a negative, it would based on sine and cosine. So fill in what you need. Sine of theta is 24 25ths divided by 1 plus cosine theta. So 1 plus 7 25ths is what I have written down. And then, folks, you're back in middle school working with fractions, your favorite friends. Okay.
Well, from the bottom, we already have that because we did it.
Yes, we do. So 24 25ths, if you want, divided by 1 plus 7/25 is going to be 32/25. You're ahead of me.
What do you mean we already have it in us?
Because in the previous problem, we added 1 plus 7/25 over here.
Yeah,
Taylor's going back and saying that 1 plus 7/25, 1 plus 7/25. We found 1 plus 7/25 to be 32/25. So guess what? It's still 32/25 is what she's saying. I saw what she was saying. I agree.
So I was like, why would we do it again if we can just put it from the left?
So officially, to divide fractions, I should multiply by the reciprocal. It is highly advisable that you cross cancel here.
Yeah, that's 25.
You have to cross. I'm resisting the urge to say you're being kind of stupid to not cancel the 25s here. Okay? That's not the word I should use, but, okay, guys, cancel those 25s, right? Whether you cross cancel on the 24 and the 32 is up to you. You're either going to say 24 over 32 and reduce that, or you're going to cancel right now. But 24 and 32 both divide by 8. Go big or go home.
Yeah.
If they both divide by 8, we are at 3 over 4. That was a prank call. Okay.
That one wasn't bad. Thank you.
Okay. Got one more example to work through. Are you ready?
Yeah, now there's a pie.
Well, it's the same as 3 theta over 8, right? Or, no.
Nope. Pi is pi, not a variable. Okay. Last example. Use the half angle identities. Okay, so it's telling you half angle identities, right? You read it. You saw it. To find the exact value of sine of 3 pi over 8. In other words, I don't want to know what your calculator tells me sine of 3 pi over 8 is. It will give me some lovely decimal. I don't want that decimal answer. I want to know what this is in terms of fractions and radicals. Okay? That's what I need to know. So, my job here is to find sine of 3 pi over 8, correct? And it told us to use a half angle identity. So now the half angle identity is sine of something divided by 2. Are you seeing what I'm saying? Let me zoom in back in some here. Because there's some thinking we have to do here. So we're being asked to use the half angle identity, which is sine of whatever variable, right? It's supposed to be u. So here's what we have to do is we have to figure out what goes in this blank up here that we're going to use that's going to make this expression, sine of something divided by 2, is equal to sine of 3 pi over 8. So what I tend to say is what number or what value divided by 2 is going to equal 3 pi over 8. Which really, if you want to know what divided by 2 equals 3 pi over 8, what do I really need to do? Multiply it by 2. If I'm asking what divided by 2 gives me 3 pi over 8, well, the opposite of dividing by 2 is to multiply by 2. So what you really need to find is you need to multiply by 2 to get our starting value. When you multiply by 2, 2 over 1. What is 3 pi over 8 times 2 over 1? 6 pi over 8. That reduces to 3 pi over 4. So that's our starting step to use the formula then. Okay, and again, exact value. I'm not touching my calculator here is the point. So now we're going to use this right here. Sine of 3 pi over 4 equals 2. Excuse me. Sine of 3 pi over 4 divided by 2 is what I was trying to say. Wrong word came out. Okay. Yes, this is our u over 2. Okay, so basically what I'm putting in for u is 3 pi over 4. Okay, grab your half angle identity from above. Sine of u over 2 is equal to plus or minus square root of 1 minus cosine of u. What is u? The value we just found of 3 pi over 4, and then divided by 2. So the idea here is that we have an actual exact value to use.
Okay, so do we use the calculator for
Nope.
cosine of 3 pi over 4?
Nope, no calculator. If you throw a calculator in here, you won't get an exact value. You'll get a decimal rounded value. Do you want to worry about the plus or minus now or later?
Well, since the sign is positive,
Yeah.
And here's what you have to look. Well, if we're looking at the fact that we're finding sine of 3 pi over 8, where's 3 pi over 8 going to be on the unit circle?
Do the first or second quadrant.
Well, and this is, okay, so if I say, I'm going to throw in degrees for a moment. What is 90 degrees on the unit circle? Pi over 2. So what is 3 pi over 8 in relation to pi over 2? Smaller, because what is pi over 2 in terms of eighths? 4 pi over 8, right? So the point I'm trying to make here is that if we're trying to figure out eighths, this is where you have to think, okay, pi is 8 eighths, right? 8 pi over 8. This is 4 pi over 8. Where is 3 pi over 8 in relation to 4 pi over 8? It's over here, isn't it? So we are in quadrant 1 and going to be positive. I guess I'll put positive. Square root of 1 minus. Okay. Cosine of 3 pi over 4. Think chart. Think unit circle. Officially, 3 pi over 4 is over here in quadrant 2, yes?
Yeah.
What does 3 pi over 4 relate to? Over in quadrant 1. Pi over 4. What is the cosine of pi over 4 according to our chart? Square root of 2 over 2. Now, we want 3 pi over 4 though. And what do we know about cosine in quadrant 2?
Oh, it's negative.
It's negative. So we're going to use negative square root of 2 over 2. And yes, you could look at the ordered pair. I try not to teach like that because you won't have the ordered pairs provided. I need you to understand why it's negative. Okay, so pi over 4, let's see, do I have my chart here? So according to our original chart, yes? Cosine, pi over 4, square root of 2 over 2. Agreed? Okay, that's quadrant 1. That's our reference angle to use because here we're at pi over 4. 3 pi over 4 is also at pi over 4 over here, isn't it? But we are talking about, in our particular problem, we're talking about the cosine of 3 pi over 4. All students take, come off the paper, calculus. So what do we know about this quadrant? Sine is positive. Everybody else is negative. And so thus, cosine of 3 pi over 4 is negative square root of 2 over 2. Okay? So when I fill this in right here, I'm going to fill in, it's 1 minus negative square root of 2 over 2. All over 2. Okay. I agree. It is 1 plus square root of 2 over 2. Now, I'm going to kind of treat this like some of the other problems we've just been doing, in that we're going to add on, we're going to add those on top. What is 1 as a fraction that will add to radical 2 over 2? 2 over 2? Here, I'm going to just jump right to. There are. So it's going to be 1 plus square root of 2 over 2 all over 2, correct? And that's under a radical. 1 is a fraction that we'll add is going to be 2 over 2 plus radical 2 over 2 all over, guess what number? 2. Are we okay with what I did there? Okay. Add those numerators. So what is 2 over 2 plus radical 2 over 2? What's 2 plus radical 2? 2 plus radical 2 over 2 all over another 2.
Imagine explaining this to somebody who doesn't really understand what's going on, and they just hear thousands.
I'm just saying, explain it to someone that can't see me writing it. That's the bad part. Now, fraction divided by a fraction. What's 2 as a fraction? 2 over 1. Do you see how I'm going to write this next?
Yeah.
Keep the top fraction. 2 plus square root of 2 over 2. Change division to multiplication. The reciprocal of 2 over 1 is 1 over 2. That's what I'm going to write under my radical as on my next step on the paper. Does that help some? Okay, so I'm more at the bottom of the paper than I thought I was. Yikes. So we just said it's going to be 2 plus square root of 2 over 2. That's my numerator. It's divided by 2, which is times 1/2. So it's the idea that this denominator of 2 is that denominator of 2 right there. Okay. This numerator here, the 1 plus 2 radical 2 is that fraction there, if that makes sense. Okay? From here, it's just doing the math, cleaning it up. Square root. 2 plus radical 2 times 1. 2 plus radical 2. Denominator. 2 times 2. 4. In case there's any question out there. 4. Okay. Okay, and do remember we already talked about we're positive because we're in quadrant 1. Okay, I never wrote that down earlier. There is one more definite simplification I would like you to do.
You can square root the bottom and then keep the radical.
Right. Okay, we talked earlier about how you can take a numerator or denominator square root. I didn't save it. So that 4 on bottom, we can take the square root of 4, which is 2, and then my radical is only on top.
So we have some radicals.
We do have a radical under a radical, and there's nothing we can do about that. Not in this case.
It doesn't look pretty, but it's not necessarily.
But it's an exact answer. Come on, computer. Okay. So,
Now that's one of those that if you told somebody they want
square root of 2 plus the square root of 2 all over 2.
In this case, could you divide everything by 2?
No.
Yeah.
You can't divide, well, and the top is under a radical, the bottom is not. And, I mean, that right there is the key. Okay? You can write your answer like this. The other option, I can't remember which way the answer key book writes it. Remember earlier how we factored out the denominator out front as a fraction? My denominator is 2, yes? So an equivalent way to write this, if I factor out a denominator of 2, that's factoring out a 1/2, and you can put the 1/2 in front of the square root of 2 plus radical 2. And that is an equivalent, sorry, I'm trying to get this so everyone can see it, equivalent way to write it. So the denominator of 4 was right here under, this was all one big square root. Yep. And so if you look carefully here, this is not under a radical like it was in the previous step. Yep. That was the question of what happens to the 4.
Yeah.
Yep. Okay. I don't even have a place to write down the stinking homework assignment. I know, I'm going to backtrack. I'm going to have to backtrack to the top. If you have not written down the homework assignment, we'll have to talk about parts of it, that's for sure. Page 432. 11 through 14. 31 to 36. 39 to 42 is what I am saying. There it is. Yes.
I have a question about the homework. We'll start working on it, and I'm really struggling.
Yes, hold on.
Say what we were